Let's look at the ways in which MATLAB represents and understands numerical data. Normally when programming, it's easy to ignore data types and just assume that the program knows what it's doing. The assumption is that MATLAB will give the exact answer to any calculation because it uses so many decimal points that the error is extremely tiny. However, these tiny errors can cause huge problems, making it important to have some grasp over the difference between different types of ints and doubles. For an example of this, see roundofferror.m in the exercise files. This graphs two exponential decay sequences on a logarithmic graph. We'll go into more detail about the exact mechanics behind graphing and how to use graphing functions in a later video. Both sequences change by the exact same amount each time. The only difference is a starting point, so they should be parallel. We would expect both sequences to go uniformly downward in a straight line, but that's only true of sequence x. Running this sequence yields a graph where x is going down uniformly as expected, but sequence y goes down parallel only for a while, and then suddenly turns upward and diverges. This occurs because of the specific way MATLAB rounds off very small numbers, and as we can see, the end result is more than 1 trillion times higher than it should be. There are several ways of dealing with problems like this. First, we can change the data type. Depending on the type of problem, switching from a less precise data type to a more precise one may reduce or remove round-off errors. On the other hand, switching to a less precise data type where precision isn't as important can save space on your hard drive. Either way, to change the data type, use the name of the new type as a function with the variable or number inside. For instance, if I go back to the command window and type x equals uint64 of 1024, then x will be defined as a 64-bit unsigned integer with a value of 1024. Note that data must be of the same type in order for it to be combined in an expression, so it's good practice to pick a single data type and use it for all values in your program. The other way of dealing with round-off errors is by using symbolic arithmetic. This means that MATLAB will consider data as rational fractions rather than decimals, which completely removes all rounding. Using symbolic numbers requires the symbolic math toolbox, which we will cover in more detail in Chapter 5. The downside of using symbolic math, though, is that symbolic arithmetic is significantly slower than ordinary floating point arithmetic. To use symbolic arithmetic, simply put SYM and parentheses around each of the numbers that you use to designate it as a symbolic data type. Be sure to put this around all of the numbers in variable assignment statements because you must have data of the same type in order for MATLAB to be able to do a calculation with it. Looking back at the previous example, if we go back to round-off error and add SYM around each of the two variables in sequence y, then when we graph it again, we will get the correct result. As we can see now, both of the lines are now going down in a uniform and parallel fashion.